Hello, hello. Can you hear me?
Yes, I can hear you.
Can you hear me?
Hi, yes. Hi, can you hear me?
Okay, so your voice is very slow. I cannot hear you properly.
But I can hear you.
Okay. So now we'll start our rest of the classes. So basically, we will complete all of the things. So in this time, I will try to discuss only for the air quality monitoring. This part, how we can easily work with the air quality parameters, different types of gases. How we can easily do for the air quality monitoring using the Sentinel-5 satellite imagery and make the different types of air quality parameters present. So let's go. So basically, okay, so I simply start the recording. So now can you see my screen?
Yes, I can see.
Okay. So hi and welcome to the 7 days online training program. So we already cover all of the rest of the part. So basically today I will try to discuss about the part for which not completed. Okay. So I also try to not complete it for the air quality monitoring. So I will try to discuss all of the things in air quality parameters so that you can easily work with the air quality monitoring. Okay. So let's go. So I am course coordinator. So basically today I will try to discuss about the air quality parameters dataset, how you can easily work with this. So I will try to discuss about that nitrogen dioxide density. So basically nitrogen dioxide, sulfur dioxide, carbon monoxide or other all type of gases. The same process when you want to work with this, that totally same process for the filtering, for the displaying the result, all of the process will be same. And I also try to show you that how you can easily download the air quality parameters time series data in Excel file in CSV format, and how to convert the unit from mole per meter square to molecules per centimeter cube, and how to make the time series chart using the Google Earth Engine platform for different types of air quality parameters. You can easily make the time series chart. Okay, and finally how you can easily export this map. Okay, and make the map layout in ArcMap software like this. So in this time, here you can see nitrogen dioxide concentration map. So basically here you can see nitrogen dioxide and methane gas. So after completing this training, you are also able to make the map like this. So here you can see the two map. So you can see this is the one kind of map, the methane concentration map of Kuwait, as well as also map you can see nitrogen dioxide concentration year of 2020 January, month of January. So basically this is the two type of map where I just download the TIFF format from the Earth Engine platform and then simply make the map layout or other things in the ArcMap software. Okay, so just I simply download the TIFF images. So here you can see this is the methane concentration map. It's showing the unit is that ppb or parts per billion, and another side you also you can see nitrogen dioxide. This unit is the mole per meter square. Okay, so here easily conversion different types of unit and get the result. So in this time here you can see this is this kind of map. Just I simply download the TP image from this Earth Engine platform, and then I simply make the map using the ArcMap software for different types of lesion, title, scale bar. Okay, I add this. So I also try to show you this part. So in this time also you can see this is the another map for the nitrogen dioxide rebound. So different time period in the before lockdown, during lockdown and post lockdown in the COVID situation in Bangladesh. So this is our another types of research work. For we can also do for the monitor the what is the condition of the nitrogen dioxide different time period in the lockdown, pre-lockdown, post-lockdown, or during lockdown period. Okay. So in the same process, we are just download the TP images from this Google Earth Engine platform and then simply make the map in ArcMap software. Okay. So mainly in this time, we are using the satellite image. It's called the Sentinel-5 satellite imagery. So basically this Sentinel-5 satellite imagery is focused on air quality and composition climate interaction with the main data products being ozone, nitrogen dioxide, sulfur dioxide, methane. So all of the aerosol, carbon monoxide, okay, all of the gas, it will be get the data. Okay, we can easily access the data, air quality parameter data from these satellite images, all of the gases. Okay, and this is the website link. From this link we are easily access all of the data set. So in this time I simply open this go to this data set link and try to discuss about all of the data set, then we can step by step we will complete. So I just simply open my new code editor. So I just simply open a new code editor in here. So I just simply open a new code editor. In this time I simply click to here and then simply go to the browse data catalog. Okay, then I want to get all of the Earth Engine public data catalog. In this time I want to work with the Sentinel-5 satellite imagery, so that's why I simply click on the Sentinel, then I get all of the Sentinel image collection in here. So in this time I want to work with the Sentinel-5. Okay, so Sentinel-5 is that Sentinel-5 ProPOMI, tropospheric monitoring, you can see. So basically this data set we can use the data satellite image for accessing the air quality, and we can easily get the all of the concentration, atmospheric concentration of the ozone, methane, formaldehyde, aerosol, carbon monoxide, nitrogen dioxide, sulfur dioxide. Okay, we can easily get all of the data set from here, you can see. Okay, and all of the data set the filtering process as well as also make the time series chart, all of the things will be same. Okay, so in this time I want to work with the data set for nitrogen dioxide, so I simply click on the nitrogen dioxide. So here I can get all of the information about this data set. Here you can see. So here you can see I can get the data set for the first of all you can see this is the data set availability date. We can get the data set between this time period, year of 2018 from 2020. Okay, we can get the 18 time period. We can get the data set. Also you can see data set provider is that. Okay, and Earth Engine snippet. Okay, so in this time I just simply work with the Earth Engine snippet. I simply copy this unique ID. So basically this is the unique ID, and we already know about that every satellite image has a unique ID. It's called the Earth Engine snippet. So I simply copy this Earth Engine snippet from here and then simply paste in my code editor. Okay, so in this time I just put a variable name. You can use any variable name. I simply put the variable name. Suppose I put the variable name is that NO2. Okay, so in this time I just filtering according to my region. So suppose in this time I want to need the map for the region of I want to work with, suppose I simply use here the USDOS dataset for getting my boundary shape file. So I just simply import. So now you can see it will be imported. I simply filter and get my country boundary shape file. So I simply take a variable and give the variable name is that suppose country, and then I simply use here the table. I filtered this table. How I can filter? I want to filter Earth Engine filter equal. What's equal what? I simply put here the country name. Suppose in this time I simply put the country name is that, suppose I want to work for the Bangladesh. I simply use that the Bangladesh. Okay, and then I want to show the layer. I simply use here the map dot add layer, and then I simply put here the country. and then I simply just use at the map dot center object function for focusing center of the shapefile. My object is the country, and I simply put the Jubilee level 10. So now I can get the result for my region of interest. Suppose this boundary, I want to need the nitrogen dioxide concentration map. I want to need the map for the nitrogen dioxide concentration map. I want to need for this boundary. Okay. So in this time, I want to show this process. So first of all, I simply import my image collection. You can see I already imported my satellite image for the nitrogen dioxide. So in this time, I want to just filter, okay, according to my region, according to my time period. Then I want to show the result. So for this, I just simply take a variable. Suppose this variable, I simply put the variable name is the image, okay, and then I simply call my collection. My collection is that, and it's stored in a variable. This variable name is that NO2. I simply copy and paste here, and then I simply use a function. It's called the filter bounds function, okay. And filter bounds, mainly we are using the filter bounds function for my whole collection will be intersecting with my region of interest. My region of interest name is that country, because this variable is stored in my country boundary shapefile Bangladesh, okay. So I simply use here the country, so it will be filter bounds with my region of interest. And then I also need to select my specific time period. So in this time, suppose I want to observe what is the condition of the nitrogen dioxide any specific time period. I simply put here the filter date function and put here my start date and end date. So in this time, I just simply select my, suppose I want to observe the nitrogen dioxide year of 2020, 1st January. Yes, so then I simply put here the year of 2020, suppose January 31. Okay, I want to need this month of January year of 2022. What is the condition of the nitrogen dioxide in Bangladesh? I want to check this. So then I also need to use another thing. I need to select the specific band, okay, image specific band. Here you can see this image information. You can get the different types of band. You can see nitrogen number, column density. So mainly when you want to use this band, and then you can see the description is that mainly it is the total vertical column of nitrogen dioxide. And so this is the ratio of the saline column density of nitrogen dioxide and the total air mass factor. And this unit is that you can see mole per meter square, okay. So in this time I simply copy this band name and then I simply paste here, okay. So I simply paste here. In this time I simply paste here. In this time, when you want to check the how many images is available for this region, you can see I want to get, I simply use the print function, and then I simply use the image, and then I simply use the size function. So basically size is determined how many images is available, okay. So here you can see I can get 418 images, and this image is not captured at the same time. You can see I want to check the individual time period. So just I simply print this image. So here I can get the individual time period. So in this time, here you can see I just simply click to here and then click on the feature, okay, and here I can get all of the date. You can see, so acquisition date, okay. You can see the first image is that year of 2022, 1st January. You can see 1st January. Also you can see the 2nd January it will be start 2nd January. Also you can see the 3rd January, okay, 4th January, 5th January, 6th January. So I can get all of the date. In this time I want to reduce this image collection. So I want to need, suppose I want to need the average result between this time period. What is the condition of the nitrogen? So I simply use a function. It's called the mean function. So I want to just reduce this image collection, mean, and then I finally use here the clip with my shapefile. So my shapefile is that country. I simply copy and then paste here. And then finally I want to show the result, so I simply use here the map dot add layer, and then I simply call my object is that image and click to the run. So now you can see the another layer also added here. Okay, and I want to get the concentration map of the nitrogen dioxide. What is the condition of the nitrogen dioxide? I can easily access from here. Okay, so in this time here you can see I can get the result, but this result is not so good. Okay, so in this time I also need to add here the visualization. So here they already provide the some visualization code. So I just simply copy this code from here for the visualization, and then I simply add here. So I simply add here. So I simply add here this code. So basically in this code you can see they are make a dictionary. Okay, they are simply make the dictionary, and they are add here the minimum. They are add here the, you can see the mean. This result, it start from the 0 and up to 0.002. Okay, and they are also use here the different types of color plated for showing this different types of mole per meter square value in this map. Okay, so I simply copy this and paste here after the object name, and also put the layer name. Suppose I put the layer name is that Bangladesh NO2. Okay, month of, I simply put the January. Okay, year is that 2020. So I simply put the layer name like this. So in this time here you can see I can get the map for the colorful map of this nitrogen dioxide concentration. So in this time you can see I can get the concentration map. So in this time here you can see I can get the concentration map. In this time I get the concentration map of Bangladesh, and this map is represented the value for year of 2022 month of January. Okay, I can get the map of January. So now you can easily download this TP images. Okay, so as a TP image we already covered this part, how you can easily download the TP image. So in this time here you can see, okay, so in this time when I want to check, suppose I simply click on the inspector tab and click on this portion, then I can get what is the condition for this lat long. You can get the value, you can see. So you can also check, you can get the value. Okay, so basically this is the map of the concentration map of January in Bangladesh. Okay, so using the same process you can easily make any. So you can see it's not I only showing for you for the nitrogen dioxide, but when you want to work with the another parameters, suppose ozone, sulfur dioxide, methane, okay, you want to make the map, you just follow the same process. Okay, so in this time we are also do the lot of things using the map. Suppose if you want, you can make the time series chart. So between this time period, what is the condition, why when the nitrogen dioxide level is the high and low, so we can easily make the time series chart, as well as we can also make the how many nitrogen dioxide gas is emitted in a particular time period. I want to calculate it. Okay, so how many gas is emitted of nitrogen dioxide in Bangladesh year of 2022 January, month of January, how many gas will be emitted. So we also calculate this. So we also download the data as a CSV file format. So using the same code, I also try to show you all of the things step by step in the, using the same code. Okay, so in this time I want to show you that how you can easily make the time series chart. So before that, if you have any question, you can ask me any question about this code. Any question about this code or any doubt?
No, everything is clear.
Okay.
But I just wanted to ask one
Yeah.
thing, that is there any other data sources available for this air quality? Any other parameters? Like you have just told, it's only for sulfur dioxide, nitrogen dioxide, and carbon monoxide, right?
Yeah, carbon monoxide is available. Yeah.
And with it's only available with Sentinel-5,
Yeah.
not with any other satellite.
No, Sentinel image is not available for the air quality monitor. Mainly, Sentinel-5 is focusing the air quality parameters. Sentinel-5, okay. And now,
Okay.
not only for all of the gases, it's mainly you can see all of the gases you can available in here. You can get, but we are also doing for the different types of algorithm. Suppose when you want to work with the particular matter PM2.5 or PM10, okay, then we also need to follow the another algorithm using the another satellite images. We are easily make the algorithm for calculated the PM2.5, PM10. Okay, so in this time I will not showing the PM2.5 how you can easily do so, because this is the another advanced air quality monitoring course. Okay, so in this time I will show you that only for this how you can easily use all of the data set, how you can easily make the time series chart, how you can easily download the data as a CSV file format, how you can easily calculate the how many gas will be emitted in a particular time period, how you can also calculate this. Okay, so let's go. Okay, so in this time, first of all, I want to create the time series chart of this map. So for this, just a minute.